Hello. I'm going to discuss about the project based on cloud computing domain, and it is titled Energy Efficient Host Consolidation in Cloud Data Center. And before proceeding any further, I'd like to give a brief introduction about cloud computing. And cloud computing is a means of enabling technology, and it is a ubiquitous computing. And here, cloud refers to the network or internet, and actually, cloud computing is nothing but, in simple terms, providing services via the internet. So, it's a means of accessing the applications as utilities or services over the internet and allows us to create, configure, and customize the applications online. And any application like email, web conferencing, everything executes on cloud. We have a brief knowledge about deployment models in cloud, namely the public, private, community, and hybrid models. Here we try to concentrate on the public cloud. And regarding the service model, the IaaS or the infrastructure as a service is being the central theme of this project, and whereby the virtual machines, the servers, storage, and network are being offered as service to the end user or customers or tenants, and virtualization where it is closely linked with cloud by means of on-demand capabilities, broad network access, resource pooling, rapid elasticity, and measured service is being entangled with the concept of cloud computing, and the virtualization tries to separate the physical infrastructure to create various dedicated resources and enables to run multiple OS and applications on the same server. Some examples may be VMware, Xen, Hypervisor, or KVM are being used here. So to move on to the topic, I shall first define the aim of the project, whereby our aim is to develop an energy efficient cloud data center by means of host consolidation and energy efficient VM migration under different varying workload characteristics. And to begin with the objectives, I have developed a VM allocation policy migration algorithm, namely the multi-dimensional overload detection algorithm MODA, to provide an energy efficient cloud data center. And this particular MODA is being, that is, the algorithm is being compared in performance with the other VM allocation policies which are already existing in cloud environment, which are called as LRR and IQR, which is nothing but robust local regression and the interquartile range. These are being measured in terms of different varying metrics, as you can see from the slide. And finally, we need to conclude that we're going to conclude that MODA technique is the most optimal energy efficient solution, which actually tries to improves the overall performance of the system under consideration by minimizing the overall energy consumption. Move on to the abstract. I just want to give you a brief introduction why we are concentrating on the energy efficiency in cloud data center, because mainly data centers accommodating large applications, that is the cloud data centers, they tend to emit enormous quantities of energy, which in turn bestows a high operational cost as well as the contaminated ambience. So to have it as an environmental friendly uh, objective, as well as to curtail the enormous energy consumption as well as the high operational cost, we concentrate on the energy efficiency in cloud data center. There are two main techniques are being followed in the virtualized environment. One is being the load balancing, another one being the server consolidation. Both are on the fly resource management, which are gaining prime importance nowadays. So in my first module, my first phase, I concentrated on the load balancing technique in cloud, and the second phase deals with the server consolidation. Generally, this consolidation problem usually in existing technique concentrates only on the CPU utilization in a single dimensional manner. Rather, in our project, I'm going to implement the RAM as well as bandwidth as another two other resources being considered, to consider the same thing in multi-dimensional perspective. So this MODA technique is used to actually minimize the energy consumption, and actually provides with optimal performance as well as resource utilization in the cloud data center. Next, these are the software and hardware specification what I use for my project. You can either develop it in the IDE use maybe Eclipse or NetBeans according to our requirement and wish. And similarly, the operating system can be Windows, Ubuntu, Linux, anything. But the tool used here is the CloudSIM Toolkit, which is 3.03 as the version. Next, moving on to the phase 1. In phase 1, I actually concentrated on the load balancing technique, which is called as the weighted first come first serve algorithm, and this was being compared with the already existing FCFS, that is first come first serve round robin methodology and throttle load balancers. And considering the metrics, I found that WFCFS was the most optimal load balancing technique in terms of energy consumption, that is power consumption, execution time, and processing cost. Now in existing system, we have certain drawbacks or demerits present in the existing system. Namely, there is a lot of energy being wasted due to the idle physical machines or hosts are being kept on for all the time instead of being shut down or put to hibernate or sleep mode. So these inactive hosts tend to consume a lot of energy in the existing system, and also there is a presence of hotspot or congestion, however we call it, when two or more virtual machines try to access the same physical machines, even though the physical machine is being overloaded, and it's a single dimensional problem too. In our proposed system, here the data center is being broadly divided into 4 main categories, namely the hot data center, warm, cold, and green. And as you can see, these are the highlighted ones are the threshold values. The numerical values being given are the threshold values above which the data center moves on to the to being run in a hot DC environment, warm, and then cold and green, and that's it. So to avoid this overloading of a data center, we need to actually migrate the overloaded data centers to the cold or the green data center. So this proposed system actually tries to minimize the overall energy consumption. As you can see, the bulleted merits of the proposed system, whereby the hot spot mitigation and overload reduction are also being considered here. Next, this is the representation of the system architecture, diagrammatic representation, whereby the hosts which are overloaded or either underloaded are being shut down, and also the ideal hosts are being switched off or put to sleep or hibernate mode in order to curtail the enormous energy consumption. Next, moving on to the algorithm, this actually tries to minimize the skewness. I have been telling about a word called as skewness from the beginning, which is nothing but it is the unevenness or randomness, you can call, okay, in the multi-dimensional resource utilization of the server. And once you minimize this skewness under different workloads, they can improve the overall utilization of the resources, server resources. So upon which this MODA operates, this algorithm tries to minimize the energy consumption as well as less VM migrations and shutdowns, the host shutdown host, as well as the minimized performance degradation due to the SLA migration is achieved here. Next, this is the elaborated pseudocode or algorithm of the MODA, and you can find the different steps being involved. And the step 4 actually concentrates on the VM selection policy, whereby the host has a list of selection policies, namely the MC, MMT, MU, and RS, which is nothing but maximum correlation, minimum migration time, minimum utilization, and random selection, which we'll discuss later in the next slides to come. And here the threshold value is being checked here, and if the host is underutilized or overutilized after the allocation is being found by this algorithm, as well as we try to concentrate and calculate on the energy as well as SLA violation techniques, which is being by a numerical method, and mathematically it can be represented. Next, moving on to the VM selection. As I told before, you can see, as you have seen in the step 4, these are the different VM selection methods whereby the 4 policies are used to migrate the VMs from an overloaded host. So based on these conditions, VM is, that is a virtual machine, is being migrated from a overloaded host to a underloaded or less utilized host. Next, moving on to the modules, actual module split up, whereby the phase 1 concentrates on load balancing and phase 2 concentrates on the server consolidation. And this is simple diagrammatic representation of the modules which I have dealt with in this project. And this basically is used to achieve an energy efficient cloud data center. Next, moving on to the modules, just a recap of whatever I have told about the MODA technique. Similarly, here the same thing is being repeated with more concentration on the hotspot and cold spot, whereby the hotspot has a hot threshold value set as 0.90, and if the host is overutilized, it returns the sorted list of high temperature host. So the virtual machines move from the overutilized host to the underutilized or or to the underutilized host, whereby the migrated VMs start running and performing better in case of cold spot rather than in hot spot, whereby there is much of overloading and less quality of service being obtained. Next is the energy efficient migration. Here we have told about many things about overloading and why an overloaded host is not so appropriate in such a cloud data center. The main problem with overloading or overloaded host is that it doesn't achieve an energy efficient migration for the virtual machine. So basically, to achieve these two, we need two goals, namely the overload avoidance, whereby the physical machine should be sufficient enough to satisfy the resource of all VMs running on it, and this should avoid any kind of hotspot or congestion in it. And secondly, we have to concentrate on the green computing. Green scenario means we know that the ideal physical machines are switched off or turned to save energy, like they can be put in hibernate or sleep mode, otherwise switched off, shut down completely to save energy. Simply like in day-to-day life, we switch off the fans to save energy, electricity whenever it is not needed, simply like that. And same way in our green computing environment, this also needs to be done. And this is the migration which is being done, and based on CPU utilization, not only based on CPU utilization but also RAM and bandwidth are calculated for minimizing the skewness. Next is the server consolidation, which can be divided into 4 main parts, namely host overload detection, underload detection, and then VM selection and placement algorithm, as you can see. And our model of MODA, which is based on the host overload detection, is based on a method called as adaptive utilization threshold based method, whereas threshold is being set, and above the threshold means the virtual machines are they tend to migrate from the overloaded host to the underloaded or underutilized host. And next we have to have the continue with the description of that, whereby the temperature of the hotspot, then performance degradation due to migration, and SLA violation metric are being calculated in a mathematical way to show how actually the hotspot detection is being done, and the MODA technique tries to implement the energy efficient cloud data center. Next, let's move on to the experimental setup, where here the number of hosts are being fixed at a point or being specified already as predefined as 800. That can vary according to our requirement, but I have specified it as 800 hosts. Then the configuration, as you can see, whatever is being present in the CloudSIM environment, I have given it here. And next is the number of VMs being presented. Here 4 main Planet Lab workloads are being taken. This Planet Lab workload is that which is being already predefined in the CloudSIM toolkit itself. So from there I have taken 4 different environments and different workload for that matter. So this is the simulation result what I got from the by running this MODA technique, where this multi-objective, multi-dimensional objective overload detection algorithm tries to implement this workload for this particular workload with 800 hosts and 1052 VMs, and we find that the energy consumption in the console, as you can see, it is 87.48 kilowatt hour, which is much less than the already existing LRR and IQR methods. As you can see from the table here, here the number of hosts are being specified with the different parameters being varied, and our algorithm outperforms the already existing LRR and IQR techniques. So this is a comparative study or result of all the different VM allocation policies or algorithms being present under different varying workloads. As you can see, these are the different methods of comparison based on different parameters like energy. The parameters are specified horizontally and the allocation policies are being specified vertically in terms of columns like IQR, LRR and MODA techniques. And as you can find, the third or the bottommost thing is the MODA technique, which outperforms in all the parameters in comparison with the existing IQR and LRR technique. So this is again extension of all those workloads being compared. And finally, I want to show you this graphical representation of the MODA technique in comparison with IQR and LRR technique. And this from the comparative table, we have plotted the graph here showing that MODA, in terms of the energy, number of VM migrations and other parameters, outperforms the IQR and LRR technique by stupendous difference, as well as the VM allocation selection policies, namely the MC, MMT, MU and RS are being plotted, and the different colors represent the different VM allocation policies. So these are the results of the graph. So this is a comparative of the comparison between the various. Next, let's move policies. So these are the Planet Lab workloads. So to conclude this, we found that this algorithm, multi-dimensional overload detection algorithm, it actually minimizes the skewness for hotspot detection as well as mitigation of it. And compared to other allocation policies, this is the best and provides a realistic review and is most optimal energy efficient solution. And as part of the future work and research, further enhancement of this project, we are just trying to propose it to include other data center components as well. And these are the references I went through, and based on these papers and already published the proposals available, I had concluded this. And thank you for watching the video. And if you like it, just hit the button, and if you like it more, just subscribe it. And I'll be ready to answer your questions or queries too. Thank you so much. Thanks for watching the video.